Okay, now let's talk about multiplying rational expressions. But before we get into multiplying rational expressions, let's just remind ourselves, how do we multiply fractions? Well, when we multiply fractions, it's as easy as multiplying the numerators right across and the denominators right across. So in this situation, you have 1 times 9, which is equal to 9, and you have 3 times 16, which is obviously equal to calculating 48. Hopefully I did that right in my head. So we get 9 over 48, and if we simplify that down, I think you can pull a 3 out of each of those. We have 3 over 16, I think, is the simplified version of that. Okay, so the same process holds true for multiplying rational expressions. You multiply straight across, and you cancel out any like factors. That's kind of the simplifying part. So those are the steps. Step 1, factor the numerator and denominator, and cancel out the like factors. So let's look at this first problem right here. This one right here. We want to simplify this. The first thing we need to do is factor the numerator and denominator. Well, if you look at each of these numerators and denominators, there's nothing to factor. So we kind of have to move to the second step, is canceling out like factors. So let's kind of look on top and look on the bottom. Maybe focus first on the coefficients, the numbers in front of the variables. See if there's anything we can cancel. Well, look at this. Because everything's being multiplied, you can cancel this 4 with this 4. Those are gone, right? And can we do anything with this 3 and that 21? Yeah, if we take the 3 out and take a 3 out of here, what does this turn into? Well, now this is a 7, right? Because 21 divided by 3 is 7. And can we do anything with, we could even get rid of this 7 with this 14, and then we just have a 2 here, right? Oh, and look at this. Check out this. We can get rid of this 2 here with this 4, and we're left with a 2 on the bottom. So there, it looks like by the time we're done, in the denominator we have a 2 for our coefficient. So now let's start focusing on getting rid of some of these x variables. Well, notice we have, if we look on top, we have 3 x's on top, x to the third power, and we have 2 on the bottom right here and 5 on the bottom over here. And if you bring these two together, how many do you have all together? Well, you have x to the 7th. So if we have x to the 7th on the bottom and x to the third on the top, and we cancel 3 x's on the top with 3 x's on the bottom, we are left with x to the 4th on the bottom. And so we'll just take that right over here and put that x to the 4th. Now the question is, what is in the numerator? What's left? Nothing's there, right? But you gotta put something there. And in this situation, you gotta have a 1. It's just like a placeholder in this scenario, just to make things make sense. But there is a factor of 1 left on top, and we're gonna leave that there. And that's how you factor something like this. Here's your solution to that one. Hopefully I didn't make a mistake there. Okay? Now let's move down to a little bit more difficult problem. This one has a little bit more factoring involved. So let's take each of these parts and factor them. Well, this part in red, that's factored. That's good to go. Okay? Now let's take this one. We got to factor that one. I'll take that over here and factor it. I'll make my x. We put a negative 3 on the bottom, 2 on the top. What times what? We got 1 and 3, and then 3 is positive, so that one's negative. So that turns into being an x minus 1 and an x plus 3. Okay? Now let's take this one in green, the numerator of the next rational expression. We'll factor that one. We'll take that one right over here. Make our nice little x right there. We got a negative 6 on the bottom, and there's a 1. Remember, there's a 1 right here in front of this x. So we'll put that on top. What times what is negative 6 to algebraic run? I'm pretty sure that's 2, 3, and then the 2 is negative. So this turns into being x minus 2 for that, and then x plus 3. Okay? And then let's do this last one in blue. We're going to factor this right here. So we have x squared minus 2x minus 3. So we'll make our little x thing. We'll put the minus 3, and then minus 2. What times what is 3? Well, 1 and 3 are the only things, and we need it to be a negative there. So this is x plus 1 and x minus 3. Now you guys are going to be doing this a lot, so you got to be really quick at factoring some of these things. Now let's rewrite this whole thing now, okay? With everything factored. Okay, we'll start with our red. So we have x plus 1. We really couldn't factor that one, right? And then we'll put our purple in from right over here. So we have x minus 1, and then we have x plus 3. There we go with that. Now let's do the green. Green's next, right? So we're multiplying these. The green was x minus 2, x plus 3, x minus 2 from right over here, and then x plus 3, And then let's finally the blue. Let's do the blue section. We got the x plus 1, x minus 2. X plus 1, and we got the x minus 2 right there. Okay, everything's factored. Now we just got to start canceling common factors. So let's find some. We have this x plus 1 on top. Do we have any other x plus 1s? You bet we do right here. Check that one. Gone. Factored it out. We have this x minus 2 right here. Cancel out with that x minus 2 in the bottom. Remember, we want to cancel from top to bottom, not across. Oh, look at this. We got x plus 3. Cancel out with that x plus 3 right there. Anything else we can cancel? No, nothing else. We're done with the canceling. So let's just finalize this. This is equal to, okay? What do we have left on top? Nothing, but we have to put something there, right? So we put a 1. What do we have left on bottom? We have this, x minus 1. That's it. So we put an x minus 1. So you have just multiplied this and simplified it down. And our final solution is 1 over x minus 1 when all is said and done and as everything simplified. So that is how you multiply rational expressions.